GPS, a very common terminology used in today's age of technology. Whether we are searching for any store or shop or are in need to find our way to some remote location, the GPS is always at our disposal to solve all these problems. But the question arises, what is GPS and how do they do it? GPS. It is a network of 30 satellites orbiting at 20,000 km above Earth's surface in well-defined orbit. They move at a speed of 14,000 km per hour. Each satellite revolves around one of the six defined orbits around Earth, such that at least four satellites are visible from any point of Earth. These satellites are raced with atomic clocks, which are precise up to a billionth of a second. The satellite constantly transmits signals which are easily picked up by anyone with a receiver. Each signal consists of information of where the satellite is and at what time the signal is sent. We are now interested to know the fundamentals in determining the working of GPS. The first concept is distance formula and second is multilateration. Distance formula is simply V into T is equal to X. We know at what time the signal was sent and the time of receiving, so we know time taken by the wave to reach us. Hence the distance of satellite from receiver is speed of EM wave, that is c, multiplied by time taken. Multilateration is a method to determine the position of an object by the position of known object and its distance from them. Suppose we are on a plane and we know the position and distance of two objects from us. So we can be on the 2 points of intersecting circles with those two objects as center and distance as radius. GPS uses this method of multilateration but in 3 dimensions. So our position is reduced to circular plane of intersecting spheres with two satellites as center and distance as radius. Now with the third satellite, our location is reduced to 2 points and the fourth satellite eliminates the other position, giving us the exact location on Earth. And now comes the interesting part. Einstein's theory of relativity, which has says about time dilation, has a significant role to play. If it is ignored, error in positioning can be up to 11s of kilometers. There are two theories of relativity incorporated into GPS. One is theory of special relativity and other is theory of general relativity. Special relativity is a theory of space, time and motion. The key to it is the fact that motion alters time. We see time running slower for clock moving relative to us. Satellites in orbit are moving at 14,000 km per hour relative to us. Because of this theory, they gradually fall behind clocks in Earth-based receiver at a rate of 7 microseconds per day. Now, general relativity also plays a significant role. The key to general relativity is the fact that gravity alters time. Clocks farther away from Earth, where gravity is weaker, runs faster than clocks that are closer to Earth. The GPS satellites are located at 20,000 km above Earth's surface, where gravity is much weaker, which causes the clocks to run at 45 microseconds faster per day. Now, combining the effects of general and special relativity, the clocks in space run 38 microseconds faster to Earth's counterpart per day. So they are adjusted or slowed down 38 microseconds per day to give such a great precision. Like the internet, GPS is an essential element of global information infrastructure. GPS technology is now everything from cell phones and wristwatches to bulldozers, shipping containers and ATMs. GPS has touched every realm and aspect of human society, whether be it civilian users, economic and financial sector, which uses their time precision of atomic clocks, life-saving and accident prevention, and even in military, national security and surveillance. GPS is very reliable and accurate and it will even have more widespread possibilities for tomorrow.